So welcome to 9-4, and today we are talking about something called independent probability. Okay, so let's jump into that. So the first thing we need to look at is, what do I mean by independent probability? So it says independent events is the outcome of one event does not affect the outcome of another event. So that means if you're trying to find the probability of one thing happening and another thing happening, but they're separated, meaning the first thing does not affect the second thing, it means they are independent, means they're separate of each other, okay? So with that being said, all we have to do to find the probability of A and B happening here, that we're gonna take the probability of A happening and we're gonna multiply times the probability of B happening, okay? So whenever you see the word and, that's gonna be independent there, okay? So here we go. So let's take this idea and let's apply it to our examples here. All right, so the first thing I'm looking at is example number 1, and it says, a fair six-sided number cube is rolled and a card is drawn from a deck of cards. We need to find the following probabilities, okay? So the first one says, we need to find the probability of rolling a number 5 and pulling out a jack from the deck of cards, okay? So with that being said, I know that the probability of me rolling a 5, there's only one 5 on a die. There's 6 sides on a die, so there's only one 5, and there's 6 total options on that die. So the probability of me rolling a 5 is gonna be 1 out of 6. Now, if I have a deck of cards sitting to the side, me rolling that dice is not gonna affect anything to do with the cards. So when I pull out my card, that's gonna be a separate probability. So we gotta think, there are 4 different jacks in one deck of cards, right? So that means there's gonna be a 4 out of 52 chance that I'm gonna end up drawing that. So now, just like it said up top, all I have to do is multiply these two right now straight across, okay? So then 1 times 4 is gonna give you 4, and then 6 times 52 end up giving you 312. So then if I end up dividing these, that means there's gonna be a 0.0128 chance. Move that decimal place 2 over, so, right, yep. Move it 2 over, so 1, 2. So that's gonna make a 1.28% chance that this is gonna happen. Very, very low chance that it can end up happening, you getting a 5 and a jack at the same time, okay? So let's look at the next one. So the probability of getting an even number and a club, okay? So that means a club inside your cards here, okay? So with that being said, an even, that means the numbers 2, 4, and 6 on that number one are gonna end up being your numbers on that die. So that means there's 3 even numbers and 6 total options. And then we gotta think, there's 4 different suits on a deck of cards, right? So that means one of those suits, 1/4 of 52 is gonna be 13. So that means there's gonna be 13 clubs in a deck of 52 cards. So now literally all I have to do is multiply straight across, which is gonna give you 39, and I'm gonna do, which is gonna give you 312. And then when I actually do 39 divided by 312 as a decimal, that's gonna give me 0.125. 2 decimal places over, that's gonna give me a 12.5% chance that that combination is going to happen, okay? All right, and the last one, we're gonna do the probability of getting an odd and not a spade. So we have 1, 3, and 5. So there's 3. So there's 3 odd numbers out of 6. And then it says not a spade. So again, there's 4 different suits in a deck of cards. So if I take away the spades, that means there's 3 other ones that I can get. I can get a heart, I can get a diamond, or I can get a club, right? It's gonna give me a total of 39 cards. So there's 39 cards that are not a spade. And I'm gonna do that over 52 total cards. So whenever I multiply this across, so 3 times 39 is gonna give you 117. 6 times 52 is gonna give you 312. And so when I end up dividing that as a decimal, that's gonna give me a 0.375 chance, which goes 2 decimal places, which is gonna be 37.5%. So again, guys, 2 separate independent events happening. Take those 2 ratios, multiply them together. When I divide it out, it ends up giving you your percentage so you can see what type of probability is for that happening, okay? Look at example number 2. All right, on example number 2, it says, a coin is flipped and a spinner with the colors blue, green, yellow, and red is spun. We need to find the probabilities, okay? So flipping a coin and spinning a spinner are two separate things. They do not have anything to do with each other, so those are independent events, okay? So what is the probability of me getting heads and a yellow? So we know if I flip a coin, it's either heads or tails, right? Two total options, and I need one of those. So that means there's a 1 out of 2 chance that I'm gonna get a heads. And then right now, there's gonna be 1, 2, 3, 4 different options, and I'm wanting to get one of those. So I'm gonna multiply this by 1/4 because I'm getting 1 yellow out of the 4 different options. So 1 times 1 is 1, 2 times 4 is 8. It's gonna be 0.125. 2 decimal places over is gonna be a 12.5% chance that that combination is gonna happen, okay? Now let's look at the next one. So I need the probability of getting a tails. So again, I know that there are 2 options on a coin and I'm needing to get 1 tail. So I'm gonna get a 1 out of 2 chance of getting that. So now, and not green. So that means there's 1, 2, 3, 4 options. I do not want to get green. So that means there's 3 other options that I want. So I need to do 3 out of 4. So 1 times 3 is 3. 2 times 4 is 8. It's gonna be 0.375. 2 decimal places over is gonna round to 37.5%, ladies and gentlemen. So there's a 37.5% chance that that combination is gonna happen, okay? Look at example number 3. All right, so on number 3, it says a marble from a bag with the contents of 3 blue marbles, 2 green marbles, and 7 red marbles, and a letter is selected from the alphabet. We need to find the probabilities. So that means if we have 2 bags with all these marbles in it and a separate bag with all the alphabets in it, they don't have anything to do with each other. So they're independent events happening here. So we need to find the probability of getting a green and drawing a vowel. So right now I have 3 blue, 2 green, and 7 red. So 7 plus 3 is 10, plus 2 is 12. So that's 12 total. And then there's gonna be 2 greens. So I'm putting that over 12. So that's the probability of me drawing a green. And so now I need to multiply that by getting a vowel, okay? So I know there's 26 letters in the alphabet, right? Okay, and then A, E, I, O, and U are gonna be my letters in the alphabet, right? A, E, I, O, and U. So there's a 5 out of 26 chance that you're gonna end up drawing that. So then when I multiply this across, 2 times 5 is gonna give you 10. Give you 312, 3.032. 2 decimal places over would make it a 3.2% chance of that actually happening, okay? So now we're gonna look at the probability of getting a red and a letter before the letter P. So right now, I know there's 12 total and there's 7 reds. So that means there's a 7 out of 12 chance of me drawing a red, okay? And now the letters before P. There are 15 letters before the letter P. So there's a 15 out of 26 chance that I'm gonna get a letter before the letter P. So which is gonna give you 105. And then I'm gonna give you 312. And then 0.3365. So 2 decimal places over gives me a 33.65% chance of this actually happening, okay? So ladies and gentlemen, this is the percentage here. Very unlikely of that happening. A little more likely, but still under that 50% mark of it happening, okay? Let's go on to example number 4. All right, last on example number 4, a random number generator selects a number between 1 and 10, and a coin is flipped. What is the probability of the random number generator selecting an even number and the coin landing on tails? So again, doing a generator and flipping a coin are 2 separate events. So that means we're gonna be doing multiplication here because they're independent. So that means if I want an even number, 2, 4, 6, 8, and 10, there's 5 even numbers on 1 through 10, okay? So that means I'm gonna be doing a 5 out of 10 chance of me getting an even number. And then if I flip a coin and I want it to land on tails, there's 2 options, heads and tails, and I wanna get tails, so that's a 1 out of 2 chance of me getting tails. So 5 times 1 is 5, 10 times 2 is 20, okay? And then that's actually gonna reduce to 1/4, which 1/4 is a 0.25, which is a 25% chance of this actually happening if I was to get an even number and I was to get a coin landing on tails. Okay? So take this concept, move it over to your skill check. If you have any questions, please raise your hand and let me know. Have a good one.